Okay, hi guys. So in this lecture, we'll be discussing about whether a compound will undergo SN1 reaction or not. So let me start off. So we have a compound, and you just have to tell whether this compound will undergo SN1 reaction or not. Okay. So this is SN1. This is SN2. Okay, we have a compound like this. This will whether undergo SN1 or not. It will not go under both. Why? Because it is due to the formation of aryl carbocation in the intermediate. Similarly, this will also not go undergo SN1 and SN2. Why? Because of the formation of vinyl carbocation. And whether this will undergo SN1 or SN2? No. Why? The RF bond is a strong bond and F minus is a weak leaving agent. Hence, it would be difficult to remove or to break RF bond to convert into intermediate R plus. Okay, or the intermediate in which in the SN2 also it would be difficult for any strong nucleophile to even attack because of the strong bond energy of RF. We have something like this, and we are here. So in both the intermediates in SN1 and SN2, this carbocation or the bridgehead will have a sp2 character. Hence, it will violating Brett's rule. Hence, no for both the cases. You have to tell for this compound whether this will undergo SN1 and SN2 or not. So this will not undergo SN2, but it can undergo SN1 due to the CS3 minus shift. It will not go under SN2 because these three bulky groups are attached, so it would be difficult for any strong nucleophile to attack from behind the compound. Okay, so you have to tell for this compound whether this will undergo SN1 and SN2. Yes, this will undergo SN1 and SN2 for this compound. Yeah, so whether this will undergo SN1 and SN2? Yes, this will undergo, as the positive charge on intermediate will be on this carbon atom, not on phenyl ring. Hence, the formation of aryl carbocation will not take place, as some of you might have thought of. So, on this case, yes, it will definitely go and takes place in both the cases. In this case, whether this will. So yes, in both the cases, the SN1 and SN2 reaction will take place. Okay, let's take an example of this. So in this case, SN1 and SN2 both will not take place because of the formation of anti-aromatic compound in the intermediate or the product of the RDH or the rate determining step. Okay, let us see for this. So for this also, SN1 and SN2 both will take place. For this case, no, because of the formation of aryl like cation. So for this, yes, SN2 will take place. And will SN1 take place in this case? So again, as you can see that for SN2 we have a strong nucleophile, something like this or this, and you have the range. But when you see when you talk about the cleavage of C and Cl bond, actually this bond is actually very having high bond energy, just like in the case of CS3F. So this bond is actually very hard to break, but still it is very comparable to the C and F bond. So it is also not very easy to break in SN1 reaction. Okay, we have something like this. So in this case as well, SN2 can actually take place. But if you just see about the SN1, it would have something like this intermediate, and this intermediate would actually be unstable, or would not be very much stable, because of already this group is if you actually already this carbon atom is actually a delta positive on itself, and even if we draw the conjugation, then this oxygen atom, the most electronegative element or the atom, would get a partial positive charge, so SN1 will not take place. Okay, so let's discuss about this case. We have, okay, this is out of the example scope, we just take it as a sample example, separate example. So we have CS3O minus and CS3. So which will be the more stronger nucleophile? Obviously this would be a more stronger nucleophile. Why? Because CS3OH is a strong acid than CH4, hence its conjugate base would also be more stable. So stable, as this is more stable, this would be less likely to attack, and this would be more likely to attack. Okay, so in the next lecture we will be seeing the reaction of PCl5 on alcohol. Okay, so till then, good luck and goodbye.